Hello everyone, my name is He Zhengyu. We are from Practical 6. Our project is SafeTrade. Today, I will walk you through our project demo. Now, you are looking at a SafeTrade login page. Everyone can create an account to use SafeTrade. Let's log in. Here is the homepage of the SafeTrade. This is the SafeTrade, a local community item rental marketplace. It allows lenders to list items and borrower to search, request rentals, message owners, report disputes, and receive price alert. Our delivered MVP covered secure account, profile management, item listing, special and categorical search, rental request and messaging, reports with evidence support, and price notification. The application is deployed on AWS and served through an application load balance. Next, I will show you how to deploy it. First, we configure our AWS credential from the Learner Lab portal and verify the connection using this command. As you can see, the credentials are valid and we are automatically as the lab role. We then run telephone initial with our backend configuration to initialize the telephone working directory, set up the remote backend, and download the required AWS provider. Telephone initialization is complete. We then run telephone fmt to format the configuration and telephone validate to confirm the configuration is valid before deploying. Telephone plan shows that 24 resources will be added with no change or deletion. We can also see the expected output, the API URL, database endpoint, media bucket, and the container image URL. We then run telephone apply to provision everything on AWS. Now you are looking at the deployed application on AWS. As you can see, Telephone has successfully provisioned 24 AWS resources from scratch, including the VPC, subnet, security group, and RDS PostgreSQL database instance, and S3 media bucket, and ECS Fragment service, and the application load balancer. The output shows us the leaf endpoint. The API URL is pointing to our ALB on AWS US East 1. We can confirm the Flex backend is healthily by hitting the health endpoint. and the ALB also served the React frontend at the foot URL. So a single load balancer handles both the API and the front-end traffic. This proves that SafeTrade is not just running locally. It's fully deployed on AWS cloud infrastructure, provisioned entirely through the telephone as a infrastructure as code. When you first open the SafeTrade, you land on a login page. New user can click register to create an account with just an email and password. Once logged in, the system uses a JWT token to keep you authoritative across the app. After logging in, you land on the browser page. This shows all available listings. You can see the photo, title, and the daily price at a glance. Think of it like a local rental feed. Here's a MacBook rental listing I created earlier. On the detail page, you can see the specific information, category, and available rental date. If you know what you are looking for, use the search page. You can filter by keywords, category, and price range to quickly find what you need. Want to rent something out? Click List Then. Fill in the name, description, category, daily price, and the dates it's available. You can also add a photo. Click any listing, open the detail page. Full description, availability, date, and price. From here, the other user can send the requested or message the owner directly. The message page is where the buyer and seller chat. All the conversations are neatly organized so nothing got lost. This is feature I built. A large user can set a price alert for an item they want. For example, if I want a camera for under $50 a day, I create an alert. The moment a matching listing goes up, I get notified here automatically. Finally, I also built a report page. If a user encounters a fake listing or suspicious behavior, they can submit a report here with a description and evidence. It's how we keep the platform safe and trustworthy. Finally, the profile page, where the user can update their personal details like name and contact information. So that's the SafeTrade, a complete rental loop from discover item to message, reporting, and getting notified. The whole system runs on the AWS and is designed to be reliable and scalable. Now, let's look at how the architecture is designed, and I will walk you through it using the 3C4 diagram, which gives us a structured way to explain the system from the outside in. Context diagram. This is the context diagram, the highest level view. It answered one question: who uses SafeTrade and what does it connect to? We have three types of users: lenders who post items, borrowers who search and rent, and the moderator who review reports. They all interaction with the SafeTrade web application through a browser. The system itself runs on AWS. Zooming in, the container diagram shows the main building blocks inside the SafeTrade. The React front end handles everything that users see. It talks to the Flex backend API via REST over the HTTPS. The API reads and writes to the PostgreSQL database on RDS for media, listing photos, and the report evidence. File goes directly to S3 using pre-signed upload URLs. So the API server never has to handle the large file upload. Everything is packaged in Docker and deployed via Terraform. Finally, the component diagram zooms into the Flex backend. Each feature is its own blueprint. Listing, search, message, reports, and the notification. They share a common set of SQL architecture models for the database. One interesting connection here: when a new listing is created, the listing component directly triggers the notification component to check for matching price alert. And that's the important design we mentioned earlier, simply for MVP, replaceable later. These three diagrams together gives a complete picture of the system from the outside in. Next, I will show the testing and non-functional requirements evidence for our project. We did not only manually click through the front end, we also recorded, automated, and manually test evidence in the response tree. The backend automated test suite covers authentication, health checks, listing, search, media upload URLs, rental request, message, reports, alert, and notification. The latest result was 110 tests passed. We also verified the front end with a products build using the non-prime run build, so the React and Vite application can be built for deployment. In this test, we recorded the Docker and AWS deployment verification. This includes the backend health and endpoint, returning status OK, and the root URL, returning the React frontend HTML. In this test, we documented the main menu workflow: registration, login, profile, create, listing, browser, search, listing detail, rental request, message, reports, alert, and notification. This makes the menu test repeatable. For scalability, we have search scalability evidence using seeded listing and the concurrent search request. For media scalability, we designed using the S3 pre-signed upload URLs. So large listing photos and the report evidence files are uploaded directly to S3 instead of passing through the Flex API service. To wrap up, let me share a few things we learned from this project. The biggest takeaway for me is the importance of making decisions early and write them down. We use architecture decision records, ADRS, to document why we made certain choices and why we rejected the other choice. Write that down forces us to actually think through the trade-off, not just pick whatever was easiest. The second thing is start simple, but this design for change. Some of our design choices are not perfect for a large-scale system, but they work well for MVP. And because we kept the structure clean, it will be straightforward to improve those parts later without breaking anything else. If I could do this thing one more time, it would be starting the documentation earlier. The code was mostly done weeks ago, but writing up the report and preparing the demo took much longer than we expected. Overall, I'm proud of what we built. 107 tests passing, fully deployed on AWS, and every feature working end to end. Before we finish, I want to say a personal thank you to Mr. Richard Thomas and our dear tutor. This has been one of the most meaningful courses I have ever taken, and I'm truly proud to be one part of it. Your guidance, your feedback, and your recognition of our work means a lot to me and my groupmate. Thank you so much.